Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. In today's class, we are going to discuss about the concept of duality and the dual networks. So, this concept is a subtopic in the graph theory in electrical circuits. So, in the previous classes, we have already discussed about the graph theory. So, which means we have discussed some terminologies related to the graph theory in the electrical circuits. So, which means what is node and what is branch and what is tree, or what is a single node. These concepts we have already discussed in the previous classes. So, this is the extension of that particular topics, and this is one of the subtopic in the network graph theory, right? So we know already, what is the need of converting the circuit in terms of the graph, because when we go for the complex circuits, so instead of simplifying, or instead of finding some current or the voltage across that, but any particular element in that complicated circuits, so it is very easy after converting into the graph, then it is very easy to find the voltage or current across any particular element in the particular electrical circuit, right? Okay, so then here the duality or the dual network here, which means, of course, here as you can see, for example, okay, so just like a mirror image of a particular circuit, right? So here let me read this one. Okay, so the principle of the duality in the context of electrical networks states that a dual of a relationship is one in which current and voltages are interchangeable. Okay, which means in the concept of, or in the principle of the duality, and especially in point of electrical network, okay, and or in the context of the electrical network, so the dual relationship is nothing but, of course, not only this one, okay. So the voltage and currents are interchangeable, which means the voltage source can be converted into the current source, and current source can be converted into the voltage source. Not just converting, okay, just replacing. Okay, and the two networks are dual to each other if one has mesh equations numerical identical to the other nodal equations, which means nothing but, okay, so here we are just converting there are here you should understand the two concepts. One is the voltage sources are interchangeable, okay, by current sources, or current sources back to the voltage sources, and similarly the meshes are converted into the nodes, and nodes are converted into the meshes. So that is the concept of the principle of the duality. Okay, so which means, of course, the properties of the circuit will not change by applying this concept. That is, we should remember, right? Then here, just some basic conditions that we should know before applying the concept of duality and the dual networks, right? So as we discussed just now in the principle of the duality, so here the voltage source, in the duality, the voltage, if there is a voltage source, which means there is one circuit, so we are trying to draw the same dual network or duality for the particular circuit. So in that case, if there is a voltage source in the primary circuit, okay, then we have to replace the voltage source as a current source in the secondary circuit, okay, or if there is a current source, then we will replace with the voltage source. So that's what here. So the voltage, if it is a voltage source, then the current source, and if it is a current source, and the voltage source. So that's what here I have just mentioned the two arrows. So voltage to current and current to voltage. And if there is a resistor, then we have to replace with this G. And if there is an inductor, then we have to replace with the capacitor, and capacitor, then we have to replace with the inductor, right? And if there is a open circuit, then we have to replace with the short circuit, and if there is a short circuit, then we have to replace with the open circuit. Okay, so from here to here and here to here. Similarly, this one inductor to capacitor and capacitor to inductor, right? And another thing, if there is a series combination, then we have to replace with the parallel combination, which means, suppose if the two resistors are in series, then you have to connect in the dual network the series resistors into the parallel, okay, and impedance into the admittance, and KVL into the KCL, right? So based on these concepts, okay, so now we are going to apply the duality, right? So further here I am taking some sufficient examples to understand the concept very clear, right? So here, let us consider one simple circuit, and this is basically the circuit. And this circuit, we are by applying the duality principle, we are converted into like this. Then, how we are converted this circuit into the like this, that we are going to discuss, right? So here, the step-by-step procedure that I have mentioned, right? So for evaluating a dual network, so we should follow these following steps. First one is the number of meshes in a network is equal to the number of nodes in its dual network. Then how many meshes are there? Of course, here the 1, 2 and 3 meshes are there. Okay. So then these 3 meshes should be the replaced or should have the equal number of the nodes in the dual network, right? So then only we can call it as a both are the dual with each other. Of course, here 1, 2 and 3 nodes are there, right? Okay. So then the impedance of a branch common to 2 meshes must be equal to the admittance between the 2 nodes in the dual network, right? So the impedance of the, suppose here in between, let us consider here this is the first loop, okay, and this is the third loop. In between 1 and 3, how many resistors are there? One R1 resistor is there, right? So this R1 must be, okay, and this R1 must be replaced with its admittance in between the node 1 and node 3 only, because here it is in between the node loop 1 and loop 3. So that's why here you can see here in node 1 and node 3 you are having the Z1. So here R1 is replaced with G1. Similarly, in between 3 and 2 there is R2 is there, which means R2 is replaced with G2 in between the node 2 and 3. Of course, in between the node 2 and 3 here G2 is there. Then here R3 is there. Okay. So R3 is in between the node 1, loop 1 and loop 2, which means the R3 must be in between the node 1 and node 2. So you can see here this G3. R3 is replaced with the G3, which is in between the node 1 and node 2. This is also satisfied, right? Then what about the others? The voltage. Okay. So the voltage source is connected to the, which is referred to the loop 1. So then according to this duality principle, this voltage source must be replaced with the current source, okay, and which should be connected to the node 1. That's what here you can see here the node 1, which is connected to the V1 is will become I1, and the I1 is connected to the node 1. Then similarly, again another, what is the another voltage source V2, which is what is that referred to the loop 2. So which means then V2 will converted into I2, and the I2 must be connected to the node 2. Okay, so that's what here see I2, and I2 is connected to node 2, right? Then another R4, already in between what is that, is there 1, 2 and 3, R4. So here R4, as you can see, R4 is in between, this is belongs to only what is the loop 3, okay, which is there is no relation with the loop 1 and loop 2. So which means here the R3, R4, the R4 means here G4 must be connected to node 3 only. So that's what here you can see the R which is connected to node 3 only, G4, right? So this is how we can apply the duality. So that's what here the voltage source common to both loops must be replaced by the current source between the two nodes. Okay. Suppose if the voltage source, let us consider here there is a V3 voltage source in between 1 and 2. Okay. Then you must connect in between node 1 and 2. Okay. So there is a current source I3. Okay. So the I3 is in series with G3. So that is what this point means. Then the open switch in the network is replaced with the closed switch in its dual network, and vice versa. Of course, here there are no open or closed switches, so that's why in the dual network also we don't consider any open or closed switches. So this is how we can apply the concept of duality in an electrical circuits. Then let me take another example here, right? So, or for simple understanding, okay, so here I have written here itself. Okay, so the same way we are going to represent here. Okay, so let me, of course, here anyway I have mentioned both the circuits, but you just try to understand, okay, how this circuit can be converted into its dual network, right? Yeah, so initially this is the circuit. So how many loops are there, or how many meshes are there? Two meshes are there, which means in your given circuit also the two nodes present, right? So 1 and 2. So what are the elements connected, or what are the elements present in the loop 1, or which refer to only loop 1? Two elements, which is L, and another one is the voltage, right? So let us consider one reference also. So then these what is that inductor? Okay, we know according to the duality this inductor is replaced with the capacitor. So then, because this is only related to the loop 1, which is not related to 2 also, okay, only loop 1, so that's why you just write, okay, I mean replace this with one capacitor, and again voltage source replaced with one current source. Then coming to the second one, second loop again R is there and current source is there. So R can be replaced with the what is that, the impedance, okay, Z, and current source can be replaced with V. So of course this element we have done, and this element done, and this element done, and this element also we have done. Only the two elements which are in between, which are common to node 1 and node 2, right? So in which are common to node 1 and node 2, okay, so of course here, sorry, yeah, so capacitor only there. So this capacitor can be replaced with this inductor in between node 1 and node 2. So similarly you can see just 1 and node 2, right? So there is a reference node, let us consider this one, right? So in between 1 and R, so how many are there? One is capacitor is there, one is current source is there, and these two are connected in parallel. So that's what here what we are doing here. So one is the current source, and another one is the capacitor. Okay, and for the second circuit, of course, here again the same way. One is the susceptance G, another one is the voltage source, because the current source is replaced with the voltage source V. Then in between 1 and 2, this capacitor is replaced with inductor, so that's why here inductor. So this is L, I, C, G, V. So now this is the duality of this particular network. Of course, see, same, equal. So this is how we should apply the concept of duality, right? So next, another complicated circuit. Okay, so here also, see how many loops are there? 1, 2, 3 loops are there, which means 3 nodes. So 1, 2, 3. Anyway, one reference node will be there, right? Yeah, first of all, identify what are the elements which are exclusively connected to only loop 1. What are the elements? This one, this is first element, and this is the second element, right? So the first element can be replaced with the what is that? This is inductor, so capacitor. So here it is node 1 and node 2 and node 3. So which means these two elements, 3, yeah, this is third one. So these 3 elements must be connected to only the node 1, or in between node 1 and reference 1. So there should be no connection between the node 2 and node 3, right? So that's why here 1, 2, what is that? Okay, inductor can be replaced with the capacitor, right? And inductor can be replaced with the capacitor. And here where is another one? Yeah, this voltage source can be replaced with the current source, and another one, this voltage will, I mean the resistance will be replaced with the impedance. This is we usually considering as a G. Okay, or let me consider here, because which are referred to the 1, so I1, and this is C1. Then again, how many elements are exclusively related to loop 2? Here this one, and this one, 2 resistors. So these 2 resistors must be replaced with this impedance. So 1 and another one, So let us consider here it is related to 2. So 1 by G21 and sorry, not 1 by G21 and G22. Let us consider G21 and G22. Then what are the elements which are exclusively related to loop 3? Okay. So again, one capacitor, one resistor and one inductor. Okay. So these three can be replaced with here the capacitor can be replaced with inductor. So let us consider here it is L3 and the inductor can be replaced with the capacitor. So let us consider this is C3 and again the resistor will be replaced with G. Let us consider here it is G3, right? So now these elements are over. Now the elements common to the loops. So here this capacitor is in between the loop 1 and loop 2, which means this must be connected in between the node 1 and node 2 and the capacitor must be replaced with the inductor. So in between node 1 and node 2, right? So let us consider here it is L12, right? And another thing, yeah, this current source is also connected in between node 2 and node 3, right? So then this current source can be replaced with the voltage source. Of course, here the voltage source. Let us consider here it is V23. Okay. So now this is the dual. This is how we can draw the dual network for the particular circuit. So let me take one more example because in all these examples I have already drawn. So that's why maybe you may get confused. Okay. So here let me draw one simple circuit and for that from that circuit, so how we can convert into the dual network. So this is one capacitor and let me write here two resistors are there and then here one more voltage source is there and in between one capacitor is there again. And another thing, let us consider here one more capacitor is there. Sorry, resistor is there. So let me consider here it is, of course, I'm not indicating anything. Okay. So now here we need to convert this one into the dual network. Then how we can convert? So here how many loops are there? Loop 1, loop 2 and loop 3. Right. The same way, first let me draw. So which means here it is node 1, here it is node 2 and here it is node 3, right? So then first of all, what are the elements which are exclusively connected to node 1? So which means one reference node anyway, one is there, just we usually consider. So which means 1, 2 and 3. So what are the elements which are exclusively connected to the loop 1, which is this capacitor. So capacitor can be replaced with inductor. So which means here it is like this, right? Then coming to the loop 2. So this voltage source is exclusive connected to the loop 2. So that's why this can be replaced with one current source. And again, this resistor is exclusively connected to loop 3. So which means this can be connected, sorry. This can be connected like this. Okay. So this is L and this is I and this is G. Right. Now, what are the elements in between 1 and 2? Here this resistor. Okay. So which means because this is loop 1 and 2, so we should write in between 1 and 2. And now in between 1 and 3, again one more resistor is there. So we have to just draw in between 1 and 3. And then in between 2 and 3, one more capacitor is there. Then we have to replace with inductor. Right. So this is how we can convert that particular circuit into duality. Then now draw the dual network here. Okay. So just draw these, what is that, the green color lines. So anyway here, how we can, so 1. Okay. So just let me write here it is 2 and here it is 3 and here it is, what is that? Some reference node, right? So 1, 2 and 3. So in between 1 and so what are the elements? One is for one it is connected. Okay, so where it is one, yeah, one is connected to the capacitor. Okay, so one is connected to the capacitor, 1 2 3. So one, which is one is connected to the inductor. So one is connected to the inductor, and in between, first let me write in between 1 and 3, 1 and 3, one resistor is there. So G, and in between 3 and 2 also one resistor, in between 2 and 3, yeah, one inductor is there, right? And for particular 3 3 2 here, one G is there, and this is L is there. And 2, where is 2? Yeah, 2 2, here it is one, what is that, the current source is there. So how many elements are there actually here? This is 1 2 3 elements. So which means here 1 2 3 elements, and here it is 4, and here it is 5, and here it is 6, right? So 1 2 3 4 5 only. But what about the 6? 6 is in between 2 and 3. Yeah, in between 2 and 3 is there, and between 1 and 3 is there, and between 1 and 2, yeah, 1 and 2, one more resistor is there. So 1 and 2, this one, yeah, 1 and 2. Okay, so this is again G. So now this is the duality network for this particular circuit. So this is how we can apply the duality for the dual networks concept, right? So I hope everybody get understood. Okay, so this is very simple, just need to practice. Okay, if you just practice one or two what is that or problems or circuits, then you will get understand very clearly. Thank you. In the next class we will discuss about the next topic.
Like, share and subscribe. Hit the bell icon for more updates.